Hello, everyone, and welcome to another edition of our NACE Calgary Zoom webinar series. I'm your host, Brett Johnson, Program Chair for NACE Calgary. So with heavy lockdowns and restrictions again occurring in our province, I imagine most of everybody is watching this from the comfort of their own home, which makes me really glad we started up this series in the first place. So a big thanks to everybody who's been involved to make this web series a success so far today. So today's webinar features Sankara Papavinasam, President of Core Magnet Consulting. Sankara has provided consulting and expertise to companies all over the world with a focus on internal and external corrosion management. Sankara's long line of industry contributions include over 100 published industry papers and his own book on corrosion control. He has also acted as a subject matter expert to government committees in Canada and the US. Sankara, we're extremely pleased to have you join us today.
Thank you, Brett. It's good to be here. I'm excited to listen to what questions I'm going to get.
That's awesome. Well, so can you tell us about your presentation today?
Yes, thanks, Brett. Before somebody asks questions, I will ask the first question. How many of us are familiar with NACE SP0113 pipeline integrity methods and selection? If you are familiar with, show a thumbs up or send a kind of smiley face. Today's presentation, I am going to discuss a bit of 0113, for which I am the DPM, that is Document Project Manager, a fancy title in the new NACE Standards Committee, which means you are a chair with no vice chair. The document focuses on selection of pipeline integrity methods. But if you read the title, it focuses only on selection, but not on the implementation. Also, it focuses on corrosion assessment, not the whole aspect of integrity management. The third question is, how does this document fit in a regulatory environment? I'm going to cover some of them in the webinar today. In addition, there is going to be a series of webinars hosted by NACE headquarters on this document. If you're interested, give me a shout. We will join together to revise the document.
That's awesome. Well, thanks for that, Sankara. Well, none of this would be possible without our annual sponsors. Their contributions allow us to provide this webinar series to all of our membership here at no cost. So today, I'd like to highlight one of our gold sponsors, RISECO Corrosion Services. So RISECO Corrosion has been a longtime supporter of NACE Calgary and NACE International. All their technical staff either have NACE certifications or diligently working towards the necessary achievements in order to satisfy those certifications. They believe that NACE education, along with applicable experience, is the cornerstone of their organization. RISECO's success is built off the 5 pillars of service, integrity, innovation, knowledge, and excellence. RISECO Corrosion offers a complete set of services and equipment for all corrosion monitoring needs. And of course, all of our other annual sponsors are a huge reason why you can do what we do. Our sponsors help fund several initiatives that NACE Calgary takes on to promote the knowledge of corrosion, sustainability, and asset integrity to the next generation of engineers. To each one of our sponsors, we thank you very much for your continued support. So to see this webinar and some of our past webinars, be sure to check out our website at nacecalgary.ca to get the YouTube channel link and other details on upcoming webinars. So Sankara has pre-recorded his presentation. Be sure to stick around after the presentation as we'll move into a live Q&A session. So please submit your questions to Sankara using your Zoom client by clicking on the Q&A buttons on the screen. If you're joining us from YouTube Live, please enter your questions in the comments field and I'll be sure to ask them. So without further ado, here is Sankara's presentation.
First of all, I would like to thank NACE Calgary section in organizing this workshop, and thank you all for joining. In this webinar, I will discuss pipeline integrity methods, specifically on their selection and implementation. Pipelines are the safest, most economical, and most convenient mode of transporting oil and gas. They exist because they convert the lower value hydrocarbons to higher value hydrocarbons. That is, the dollar value of hydrocarbons at the end of the pipeline is higher than that at the beginning of the pipeline. However, during transportation, some dollar value is lost due to various reasons. Primary reasons include financial issues, regulatory issues, environmental issues, and risk in operating the pipeline. The risk may arise due to improper material selection, improper design, improper operating conditions, physical damage, either due to natural causes or due to human activities, and of course, corrosion. The best source for understanding the pipeline performance is the Alberta Energy Regulator's statistics. If you reviewed the 2017 to 2017 reports, you would find that of the 1,000 incidences that have happened, 33% were due to improper material or improper design. 5% were due to improper operation. 10% were due to physical damage. And corrosion caused almost 50% of the incidences. Fortunately, these risks do not occur simultaneously, but at different times during the life of the pipelines. If we plotted the number of failures versus pipeline lifetime, it would have a boat-like appearance with three distinct phases. At the beginning, the risk is high, but it will decrease with time as we optimize material, design, and operating conditions or operational conditions. In the constant operation phase, the risk is relatively low and constant with time. Almost 90% of our pipelines operate in this phase. During this phase, physical damage to the pipelines due to earth movement or third-party activities may occur. As we continue to operate the pipelines, the risk will again start to increase, primarily due to corrosion, cracking, and fatigue. Almost 50% of the incidences happen in this phase. We implement integrative management program to reduce or to avoid risk during various phases. The integrative management program consists of three activities. First, we assess the risk and quantify it, for which we normally use risk matrix. Though 4x5 or 4x4 grids are available, most prefer 5x5 grid as shown in this graph with 5 colors. Red indicating risk being at the dangerous level, orange indicating the risk being high, yellow indicating risk being moderate, greenish yellow indicating risk being minimum, and green indicating risk being low. Before implementing mitigation strategies to bring the risk down from the red or orange zones, we normally perform cost benefit analysis or CBE. To reduce risk or to increase reliability, we incur cost. Spending money should bring us benefit. Depending on the types of pipelines, operating conditions, and other factors, the relationship between reliability and cost may take three forms. If we implemented the integrity management earlier, smaller amount of dollars spent will reduce the risk tremendously, as represented in graph A. In this scenario, penny spent today will earn a dollar in the future. This is the most favorable situation. If we delayed implementation of the integrity management program, then the dollars spent will proportionately increase. Further, the risk reduction is equal to the dollars spent, as represented in curve B. That is, dollars spent today will earn a dollar in the future. This ideal scenario almost never happens. Finally, if you do not adequately take care of your pipelines, then the risk will reach higher level and huge expenditures are required to bring the risk to a lower level, as represented in curve C. In this scenario, the dollar spent today may only earn a penny or dime tomorrow. Not ideal at all. Once we establish a budget, we undertake risk mitigation activities, which may be repair or replacement or implementation of other corrosion or risk control strategies. Again, if we implemented the mitigation activities earlier, the benefits are higher. For instance, if we implemented the mitigation strategies when the risk moves from low to the alert level, that is as low as reasonably possible level, then we can keep the pipeline operating at low risk level, that is in the green or greenish yellow color. If we implemented the mitigation strategies when the risk is in the alert level, then you can keep the pipeline operating either in the alert level or low risk level, that is greenish yellow or yellow color. On the other hand, if we implemented the mitigation strategies later, that is only after the risk has reached higher level, then the pipeline may operate either in the orange level or in the red level even after implementing mitigation strategies. NACE Standard 0113 Pipeline Integrity Methods Selection describes various types of integrity management. The most common is pressure testing or hydro testing, in which we hold the pressure of the pipeline at a higher pressure, higher than the normal operating pressure, and monitor if the pipeline leaks. And if it did not leak, then we start the operating the pipeline. The second most common method is inspection. Inline inspection is very popular for piggable pipelines. For non-piggable pipelines, NACE has developed the DA program or the Direct Assessment Program, which has got 4 steps. Step 1, pre-assessment. Step 2, indirect inspection, which will involve above ground surveys for the external corrosion or modeling for the internal corrosion. Step 3, is the direct inspection, and step 4 is post-assessment. Industry currently uses either inline inspection program or DA program. At the 2007 Banff Pipeline Workshop, a group of professionals came up with the 5M methodology as an all-inclusive integrity management methodology. In this methodology, the model provides the starting point, or it provides the roadmap. If the model predicts higher risk, then we implement mitigation strategies. Third, we monitor the pipeline once in a while to ensure that the pipeline is behaving in the manner in which the model has predicted, or to ensure that the mitigation strategies implemented are working properly. Fourth one, we carry out maintenance activities as required, just like we take the car to the auto shop once in a while for service. All these 4 activities should be coordinated, funded, and supported. That involves upper management. As you can see, that all other integrity management types, whether it is inline inspection or DA, they are all a subset of the 5M methodology. With this background, let us now go over various activities we carry out in different phases. Before we start up operation, we must and we will select appropriate material, establish appropriate design, and then carry out the operation accordingly. If the things are not done well or not done properly, the pipeline will fail during the pressure testing or the hydro testing. CSA Z662 provides good guidelines on all these activities. It should be further noted that material for shower service must be selected as per NACE MRO 175 or ISO 15156. Also, all water used for hydro testing must be removed and the pipeline must be dried before startup. Otherwise, the wear out phase will appear than you planned due to internal corrosion. NACE is working on a document TG440 on guidelines to avoid side effects due to hydro testing. Integrity management activities in the constant operation phase. The constant operating phase is a misnomer in our industry, as our operating conditions change hourly, weekly, monthly, and yearly. However, it is important that we track these changes and understand the implication of these changes. For this purpose, Integrity Operating Window concept, published by American Petroleum Institute, API 584, is very valuable. The premises of IOW are that if we operate the pipeline within the optimal operating conditions, the pipeline will be safe. If the pipeline is operated at standard high or standard low levels, far away from the optimal conditions, then failure will occur quickly. If we sustain the activities, sustain the operation at those levels. Finally, if the pipeline operates at a critical high or critical low levels, that is far away from the optimal conditions established, the failure will occur quickly. I am aware of a situation in which a particular pipeline was protected with an external coating that was rated to 40 degrees centigrade. And during operation, the temperature exceeded 80 degrees centigrade just for 4 hours. And that completely destroyed the coating. The company had to recoat the whole pipeline section. So it is very, very important to understand the variations in the operating conditions. Now, during the constant operation phase, what can we do to prevent physical damage externally happening? Note, the external damage may be caused by two events. It may be natural or human-made. Slope monitoring using inclinometers is commonly used to track variation caused by natural causes, such as floods, earthquake. To avoid disturbance caused by human, we have Alberta one call program. We could also place warning signage between the pipeline and the earth surface and hope that the construction crew will notice it and stop the construction. Or we could install security monitoring system using, for example, fiber optic cable that will provide warning as soon as a disturbance or activity has started. The most prominent risk in the wear-out phase is internal corrosion. Note that Alberta regulations require that you evaluate internal corrosion mitigation program annually. NACE standards and Canadian Association of Petroleum Producers (CAP) provide lots of guidelines and standards that provide tips and guidelines. They should be used to assess and control internal corrosion. Models provide a good starting point to control internal corrosion. However, the success of internal corrosion model depends on two factors. First, the ability of the operators to at least provide the mandatory input parameters as indicated in the blue color, both construction as well as operation. Most of our pipelines are constructed using carbon steel. So the model, internal pitting corrosion model, should address the pitting corrosion of carbon steel. The second thing, the model should have the ability to predict the locations of internal corrosion, corrosion damage mechanisms, CDM, and overall corrosion rate, considering all CDM. To begin with, start using two NACE standard technical reports to understand and select models. Test report 21413 provides evaluation criteria using 13 different criteria. It also compares 17 commercial models. 21410 provides 6 steps to select an appropriate model. First, you establish the evaluation and selection criteria. That is, understand what data you have and what you want to get out of the model. Second, you understand your corrosion damage mechanisms, CDM. 13 CDM can occur during operation internally. Prominent among them is localized pitting corrosion. Whatever you do, please do not use a model that converts general corrosion rate to localized pitting corrosion. Science and large amounts of field data collected over 75 years have clearly indicated, as given in this diagram, that there is absolutely no correlation between general and pitting corrosion rate. Note that this plot is a log-log plot. In my opinion, using general corrosion rate to predict pitting corrosion rate is analogous to buying a lottery ticket and start spending the money assuming that you would win the lottery. The odds are very, very low. If we can take one message out of this webinar, that is this one. Do not use general corrosion models to predict pitting corrosion rate. The fourth one, we perform sensitivity analysis of the model. For example, if the model is not sensitive to hydrogen sulfate concentration, then do not use the model for sour pipelines. Establish boundary conditions. For example, if your boundary condition, if your operating condition is 80 degrees centigrade, and the model is validated up to 80 degrees centigrade, do not use the model above that temperature. Finally, understand the interior parameters used in the model. Don't assume that the model is a black box. Understand the interior parameters, science behind the model. If the models and experience indicate higher corrosion rate, then you need to implement mitigation strategies. Strategies to mitigate internal corrosion include use of cleaning pigs, addition of corrosion inhibitors, application of internal coatings, and among them, application of corrosion inhibitors is predominant. However, just do not use the inhibitors without proper evaluation. Understand the conditions to add corrosion inhibitors. Inhibitors are not effective under all conditions, especially if your operating condition changes, the inhibitor may not be efficient. Also, evaluate inhibitor efficiency using standard test methods. This is very, very important. Standard test methods provide precision and bias statements. Using the precision and bias statement, we can and we must qualify the apparatus, the laboratory, and the technicians involved in the inhibitor evaluation. At this stage, rotating cage is the only methodology for which there is a standard test method, though standard test methods for other methodologies such as rotating cylinder electrode are being developed. Finally, understand the influence of secondary corrosion inhibitor properties. Secondary inhibitor properties include water-oil partitioning, solubility, emulsion tendency, foaming tendency, thermal stability, toxicity, and compatibility with other additives and materials. This list is not exhaustive, but understand the influence of secondary inhibitor properties because they influence considerably the inhibitor behavior as well as efficiency. Commonly used internal corrosion monitoring techniques are intrusive monitoring, that is use of corrosion coupons. Non-intrusive monitoring, Example, ultrasonic inspection, UT inspection, and of course, LI lane inspection. An industry survey was presented at the BAF Pipeline Workshop 2019 that indicated that 65% of the companies are using coupons, but only 5% of them believe in the corrosion rate obtained from the coupons. What is the use of spending money on coupons? The message here is that not use techniques and collect data if you do not believe on the technology. The final risk we are going to discuss is external corrosion. Again, note that Alberta regulations require you to carry out annual inspection of external corrosion mitigation strategies. Time-tested and proven methods to control external corrosion are application of coatings backed up with application of cathodic protection. NACE, CAP, CIPA, that is Canadian Energy Pipeline Association, have published several standards and best practices on selecting and evaluating coatings and CP, as well as in understanding the risk if either coating or CP or both fail. At present, industry relies only on corrosion growth rate from inline inspection. But if you selected data as suggested by various standards and best practices that were discussed in the previous slide, you should be able to obtain at least 5 different growth rates, corrosion growth rates. In fact, developing corrosion growth rate from laboratory data is eluded in the NACE standard 662 class 9.2.6. Guidelines for converting laboratory data to corrosion growth rate are also recently published. So use data appropriately to obtain as much information as possible. Most important activity that is common to all phases is maintenance. We normally associate maintenance with the physical structure, such as pipeline. But in reality, maintenance consists of 5 interdependent entities: equipment, that is pipeline; workforce, that is us; data, communication, and associated activities, that is role of subject matter expert like me. From my 26 years of experience with the industry, I can say that the weakest link is the data. We collect lots of data, but we do not organize or take decision based on them. Or we do not collect data that will provide insight to the risks. I strongly believe that if we streamline data collection and decision-making process, we can obtain early warning on risk. Finally, let us not forget the role of management. Management is a process that ensures that the pipeline operation does not affect people, infrastructure, and environment. Management should be systematic, inclusive, proactive, continuous, ongoing, technically sound, financially viable. I would emphasize visibility and effectiveness of the management process. Management should enable us to see the structure of all pipelines in the vast network. For instance, looking at this figure, we can easily see that these are not working well for flow lines 1, 8, 14, 12, and 16 and 18. From this level, we should be able to look at the status of various activities in a particular pipeline. For example, if we want to look at flow line 1, we should be able to see what caused higher risk in this flow line. As you can see here from the details, higher risk in flow line originates due to inadequacy in implementing a couple of strategies. So we should be able to see the big picture as well as detailed analysis. And I use 7 colors for this. In addition to the 5 colors for risk, I use blue for an activity that is considered as irrelevant for the particular pipeline, or gray for an activity that has not started for the particular pipeline. Number of incidences is indirectly related to the efficiency of the integrity management program. If the integrity management program is poor, incidences will occur as illustrated in pipe 4. If the integrity management program is poor, and if no incident has happened as illustrated in pipe 3, don't be complacent. Risk will increase in the wear out fees. Be warned. If the integrity management program is good, but still incidences occur as illustrated in pipe 1, then review with field personnel on the implementation process. There are some issues with implementation process. Finally, if the integrity management program is good and implemented properly, we can safely, economically, and efficiently operate our pipelines for a long period of time, as illustrated in figure 2, in pipe 2. In summary, select and implement appropriate integrity management program that is effective, economical, user-friendly, feasible, inclusive, and appealing. In the integrity management program, include all risks that will affect your pipeline. Finally, collect data relevant to all risks and analyze them. Thank you. And I would like to once again thank Nace Calgary for this opportunity, and will be happy to take on your questions.
So with that, we're going to then jump into our Q&A session. So, so please enter your questions within the Q&A panel within your Zoom client, or if you're joining us on YouTube Live, please enter your comments into the either the comment field, or there's a chat panel on there, and I'll try and watch that as well. So to get the ball rolling on here, so Sankara, you know, what's the cost associated with running some of these different integrity management scenarios?
Tough question. We don't associate cost with integrity. We want to keep the pipelines safe. Having said that, almost all of us use inline inspection. If you assume that inline inspection is the kind of standard, if you give 100% to the inline inspection cost, in my experience, the direct assessment will be 70 to 80% of the inline inspection cost. And the ICDA will be 40 to 60% of the inline inspection cost. The benefit of DA programs is that they give pre-warning, whereas inline inspection will be a post-mortem analysis.
That sounds pretty fair. I know you kind of mentioned before that, you can't put a price on failure on that. But, in some cases, like if it was that easy, you would run an ILI on every one of your pipelines. And of course, if in the world of upstream, you can't always do that. There's lots of other, as you kind of showed in your presentation, mechanisms and other monitoring measures that you would employ before you would run to that ILI case on there. And then that's where you might run your DA programs and such like that.
Yeah, and DA programs are very effective too. And they are, in my opinion, in my experience, they are far cheaper than ILI program. 40 to 80% cheaper, depending upon which pipeline you are running and which country you are running in.
Absolutely. So that moves into my next question here. So, you showed within your presentation there, when you're dealing with risk assessment and you're trying to prove a LARP or as low as regional practical, right? How can you do that with just using direct assessment programs?
The direct assessment program rather, was established for those pipelines which cannot be inline inspectable. So if you are going to do the DA program, you must do all the 4 steps. Sometimes people start doing step 1 and 2. They don't do the dig. They don't verify the model or above ground techniques. So if you are going to do this DA program, you have to do all the 4 steps. Only then the program can be effective. It's very, very important to do the step 3, that is a digging and verifying what you have predicted. Otherwise, you may be in the wrong direction.
Yeah, it's fair enough. And sometimes doing digs are more expensive than running your inline inspections. So it's hard, if you're trying to do a pure DA program and showing that there isn't a threat.
Yeah.
Sometimes running an inline inspection might just be cheaper.
Yeah, that's true. See, just to add to that one, we established a 5M methodology because you can use DA and ILI as complementary to one another. If you do it either ILI or DA, it doesn't give a big picture. So in the 5M methodology, what you do is what will work better, what will work best for you, that's what you use.
Yeah, fair enough. Thanks for that. So a clarification question here. So within one of your slides, when you're starting up and talking about a pressure test, are you talking about, after the pipeline's in operation or as part of the design and construction of the pipeline?
No pipeline, in my knowledge, can be operated at the beginning before pressure testing. So pressure testing is a given at the startup. And then during the operation, if you make a design change or if you make other additional changes, then you will do the design pressure testing. So at the beginning, it's a must. And during operation, depending upon your change, you may or may not carry it out.
You're right. And I think in most cases, that's a pretty good assumption, because I know one of the challenges, especially when dealing with older pipelines, is you don't have pressure test records. So certainly, like you said, you can't actually start operating a pipeline without those, without there being a pressure test. So often in your risk assessment, sometimes even if you don't have those specific records, you'll make an assumption that it's at least to the code standards of that day.
Yep.
So another question here. So your presentation, it touched on some of the initial risk assessments for pipelines, and wondering what kind of, what's the source of the probability of failure that you should use based on this? Should you be using like API 579, or do you have something else you would recommend?
All of the above. So I always give this example. If you are going to drive a car in a freeway, you can predict your car speed, 100 kilometers. You can put in the cruise and drive. But if you are going to drive the car in downtown Calgary when we are busy, there is a stop and go. There is always an uncertainty. So any risk program you take, you implement, always associate itself with some uncertainty. And uncertainties, I do two things at least. Look for the standards like the API and take their probability. And two, that's what if you are doing, for example, localized corrosion models. Most of the localized corrosion models, they give an uncertainty, 10% plus or minus. Similarly, ILA, 10% plus or minus, 10%, 80% of the time. So always associate your integrity program with an uncertainty, and that depends upon your operating conditions, importance of the pipeline, and its consequence.
Awesome. I think that answered that pretty good. Thanks for that. Another question here. So in your mind, if you're looking at, say, subsea offshore pipelines, what method might you follow on that? Do you have any thoughts around that?
Subsea pipelines or subsea flow lines. Subsea pipelines, we can do inline inspection program. Subsea flow lines, it's difficult. I mentioned about the NACE document TG440. Many of the pipelines have failed because they forgot or they did not properly remove all the water after the hydro testing. So if you are going to do hydro testing, which is relatively easy for subsea when compared to other things, please make sure that you remove the water afterwards. And some companies, they also send divers to do the inspection, non-destructive testing inspection.
Fair enough. I personally haven't ever worked on offshore pipelines, so yeah, it's kind of an interesting world. There's definitely, you can't use every kind of method that you normally use. All right, another question here. So maybe a bit of clarification. So when you're using an ILI program, what are your thoughts there on whether or not you always need to do verification digs related to it, or strategic digs is specifically what was mentioned here?
That's a good question. Again, I have a slightly different view. We use inlet inspection program as a starting thing for integrity management. In my opinion, you should do the modeling first, and you should anticipate what you are going to see out of the inlet inspection. So that is one verification. Just run the model first and predict what is going to happen in the inlet inspection, and then check the model comparison, model data with the inlet inspection. That is the most ideal way. And given that even ILI vendors are saying it is 10%, 10 plus or minus 80% of the time, at least for the pipelines which are in the high consequence region, you must do the digging. For low consequence region, we may or we may not do it. For at least for high consequence, you should do the dig verification.
Makes sense. And in your mind, maybe a follow-up on that. So where, so you said are high consequence on that, do you have any ideas or suggestions on what you might classify as that? Would that depend on the specific company and what their own risk policy is? What if that is, should that be based off of specifically just class location of your pipelines?
Mostly class location. And again, if you're in the south of the border, you are mandated. Your regulatory things mandated. For example, in US, almost all non-piggable pipelines in the high consequence area, as defined by PHMSA, must undergo DA program. So here in Canada, we have a kind of little more lenient in terms of give the liberty to the pipeline operators. That depends upon the company policy. There's no one or two answers. It's a combination of all. Depends upon what works for you.
No, you're absolutely right. It's definitely a complicated question. No, I appreciate kind of that clarification on them, what the thoughts are, because you're right, there is no easy answer. And most of the time as a pipeline operator, you want to do the analysis you can to avoid doing digs, especially if it's on, you know, say minor corrosion on there where you don't believe there is a significant threat. And that's kind of what the picture your inspection is showing you as well. So maybe moving to a good segue to that. So within your presentation too, you also talked, you mentioned that most people don't really believe the value that comes from their coupons, but yet everybody still uses them. And I know in a lot of cases, you know, even a lot of risk models or internal corrosion assessments, they always take coupon rates on there as kind of a more of a validation of the model, if you will. But I mean, in your mind, if these aren't any good anymore, then how do we evolve our internal corrosion management programs to go beyond using coupons, you know, without blowing up our costs and going to inline inspections, or, you know, in some cases where we can't pig a line and we're relying on coupons because the sections are unpiggable.
Yeah, that discussion may take a couple of days to complete. See, there are two ways of taking it. One, if you are going to place the coupons, first understand where the coupons are going to be, top of the line, middle, at the bottom. And then all we have to do is whatever data you collect, you have to do a post-mortem analysis to say whether this makes any sense. Unless you correlate the data with some decision making, the data may look very bad. But sometimes the data is good because we didn't have time to do the analysis. We just throw out the data. So it is not the data. You have to correlate the data with the decision making. Even after decision making, there is no correlation, then the data is bad. Unless you do the decision making analysis, it doesn't make any help for anybody.
Maybe you want to provide a clarification on that. What do you mean if you don't make the decision on that? I'm not sure I understand like how you would, I guess, why you would not want to use coupons in that scenario. What? Because I know there could be some other examples, but how do we evolve?
Just an example. I can give the reference a little later, Brett.
Perfect.
If you compare the coupon corrosion rate at a point of the pipeline, compare the coupon corrosion rate to the corrosion rate of the pipeline, the coupon corrosion rate will be 10 to 15 times higher than the pipeline corrosion rate. So first you have to correlate why there is a difference, because the coupon is at the face of the flow. As a result, it will see the flow effect higher. So first you have to understand how the coupons are oriented, whether it is intruded or it is flushed on the pipeline surface. So we have to consider the design geometric consideration and then correlate the coupon corrosion rate with the pipe corrosion rate, and then you take a decision. For example, if the coupon says 40 MPa corrosion rate or 1 millimeter per year, that doesn't translate into a pipeline corrosion rate. That translation must happen, only then coupon corrosion rate can give indication about the internal corrosion.
Okay, that makes sense. What about if you're trying to, you mentioned in your slide too about pitting corrosion being very different from general corrosion on there as well. So can that same theory apply with coupons when you're dealing with pitting corrosion as well?
Yes. Again, when I talked about pitting corrosion, I was specifically talking about the models.
Yes.
Many models, almost 85% of the models that are out, they measure the general corrosion rate and they use a factor to convert it into a pitting corrosion rate. That is not a good way of doing it because there is absolutely no correlation between general corrosion rate and pitting corrosion rate, whether it's on the pipeline or on the coupon.
Right, but I guess my question was more related to more focused on coupons itself. So if you're trying to, like, for example, if we see, like, how do we guarantee we're getting pitting on there? Would it just be general corrosion? Can you make assumptions on there? Because you kind of talked before about being able to kind of assume whether or not the coupon's in the right position and how that might look on the rest of the pipeline. And maybe I'm mistaken. Maybe you were talking about both, but I got the impression you were just talking about general corrosion and not necessarily.
No, yeah, that's a good clarification. I was talking very generally, but if you are going to do the coupon analysis, you have to do both general corrosion rate as well as pitting corrosion rate. In fact, there is a ASTM standard G111. A group of us are re-revising it. If it gives clear direction as to what are the things you should do if you are pulling a coupon out. First, take a photograph of the coupon and do the cleanup and understand the general corrosion rate, and then understand how many pits are formed. Nowadays, we use laser profilometer to get the profile of the coupon. All these things you have to do before you take a decision based on the coupons. It is not just inserting a coupon, pulling it out, hey, this is the corrosion rate, let us go. So it's more than that.
Okay, no, that makes sense. And thanks for that clarification. So we got time for just one last question on here. So, is there any place in different direct assessment programs for what might be considered advanced technology monitoring? An example could be something like your guided wave UT.
That can be answered by you, Brett, as a pipeline operator or producer. But in the third step 3 of the DA program, there is a direct assessment, which might involve the guided wave, UT guided wave. Anything that can be placed externally to understand what is happening internally can be a good thing for the step 3 of the DA program. But again, dig 3 involves digging. So you have to find a place where you can dig and go down. So that is where the main issue is, not the technology, but the accessibility.
So I see. So you can just say, oh, look, we ran a guided UT and it fit our DA model and therefore we're done. I know as an operator, it can be challenging to make sure that you have what's, all the right elements in place to do a whole proper DA programs on your pipeline. And I know it doesn't, one method doesn't fit all. And sometimes it's kind of, you apply by through your standards, but there's not always confirmation if you've done everything you could, or if there should be more, and because there always seems like there should be more.
I can add one more thing onto that one, Brett.
Go for it.
A good carpenter makes 2 measurements before cutting it. So always use at least 2 different technologies before you take a decision.
That's very good advice. Very good. Yeah. Right. So, so thanks for that, Sankara. That was a great video, a great conversation. Really appreciate you joining us today on here. So, as I mentioned before, we are going to post this on here. The video will be in a nice, clear format that hopefully everybody can be able to read and see. So, I appreciate everybody joining us today. So we've got one more webinar series that we're going to run here before we break for the holidays. We've got Dr. Frank Cheng from the UFC. He's going to join us in about 2 weeks' time. So be sure to watch our LinkedIn to get the latest updates on when our registration site will open next week. and keep posted on that because, yeah, we're going to announce some new speakers for next year as well. So, and if you yourself are interested in sharing your research or experience or potentially an interesting case study with the industry on this platform, please email me at program@nasecalgary.ca, and we'll work to try and make it happen. So again, thanks everybody for joining us today. Please be safe out there, and we'll see you in a couple of weeks.